Good afternoon. I am Karushi Navodya. My student number is MS 25 90 97 46. Let me share the screen now. Topic for my today presentation is wireless network technologies. Network is a combination of hardware and software that sends data from one place to another place or one person to another person. This is the introduction of my presentation. These are the areas I hope to discuss with you. Network models, data and signals, transmission impairment, analog and digital signals, data transmission, and wireless transmission. In our day-to-day life, it's really important to know about wireless network technologies. There are two main standards of network models. First one is OSI 7 layer model. Second one is TCP IP model. In OSI 7 layer model, there are 7 number of layers to transmit the data. The layers are application, presentation, session, transport, network, data link, and physical layer. We can see the graphical interface of the OSI 7 layer model. In our left hand side, displays the type of the data transmit through these layers. First 3 layers are use support layers, and the network, data link, and physical layers are network support layers. And finally, transport layer is the layer which maintain the interconnection between these two layers. Then we can pay our attention to what are the functions of these layers. The application layer supposed to allow access to the network resources. Then presentation layer support to translate the encrypt and compress the data. The session layer supports to establish, manage, and terminate the sessions during the data transmission. Then transport layer supports to provide reliable process-to-process delivery and error recovery. The network layer move to packet from source to destination and provide internetworking. Then data link layer provide the hop-to-hop delivery and organize bits into the frames. The last layer, physical layer, supports transmit bits over a medium or stream and provide the mechanical and electrical specifications. The next one is comparison of the OSI model and TCP IP model. The TCP IP model have only 4 layers. The OSI model have 7 number of layers. The layers of TCP IP model are application layer, transport layer, internet layer, and network access layer. Network access layer of the TCP IP model includes the 2 layers of OSI 7 layer model. The layers are data link layer and physical layer. The internet layer of TCP IP model are similar to the network layer of OSI model. Transport layer in the both models are same. And finally, Application layer of the TCP/IP model includes application, presentation, and session layers of the OSI 7-layer model. Both are the two standard models. Then we can pay our attention on the data and signals. To transmit the data or transmit the message, it must be transformed to the electromagnetic signals. One of the major functions of the physical layer is to move data in the form of electromagnetic signals. In the topic of data can be analog or digital. The next important topic is bandwidth. Bandwidth is really important in networking. What is the bandwidth? Bandwidth is a difference between lowest and highest frequency in our spectrum. As an example, we can think the lowest frequency of our spectrum is 200 megahertz, then highest frequency is 400 megahertz. The bandwidth is difference of these values. The bandwidth is 200 megahertz. We can define the bandwidth in hertz or bandwidth in bits per second. Bandwidth in hertz means range of frequencies contained in a composite signal or range of frequencies channel can pass. The bandwidth in bits per second means speed of the bits transmission in a channel or a network. Then filters. Filters are really important to filter the signals based on the frequencies. If we need to filter our signals based on the frequencies low or high, we can filter using the correct filter. There are two main types of filters: low pass filters, high pass filters. Low pass filters allow low frequency signals to pass through while attenuating high frequency signals. Then high pass filters allow high frequency signals to attenuating low frequency signals. Then we can select the correct filter as our needs. The next topic is transmission impairment. How to know the message received the receiver correctly? Actually, what is sent is not what is received. Why? These are the reasons. Transmission impairments. The transmission impairments are the problems or errors can occur during the data transmission. First one is attenuation. Attenuation means loss of energy of a signal. To compensate for this loss, we can use the amplifiers to amplify the signal. The next one is distortion. Distortion is signal can change its form or a shape. As an example, in our day-to-day life, we can identify the lot of distortions. Due to signal problems, the receiver receive the different phases of signal. Signal components at the receiver have phases different from what they had at the sender. The next one is noise. Noise can be several types: thermal noise, induced noise, crosstalk, and impulse noise. These are the transmission impairment. The signal can happen during the transmission. The next one is error detection and correction. I already mentioned about the transmission impairment. After the transmission impairment, we must identify the errors in our signals and correct our errors in before receive the signal. This process means we can call as a redundancy for the error detection and error correction process. We must identify the errors and we need a mechanism to correct these errors. There are two types of errors can be identified: single bit error, burst error. To correct these errors, we use the error coding methods. There are two types of error coding methods: block coding, convolution coding. In the block coding, we can use some techniques such as simple parity check, two-dimensional parity check, checksum, Hamming chord, and cyclic redundancy check. Next on, analog and digital signals. What are the analog and digital signals? Before send a message, we send some voice message or text or something. These are the analog signals. Analog data refer to information that is continuous. As an example, when someone is speaking, it's an analog signal. Analog signal has infinitely many levels of intensity over a period of time. The graph A displays analog signals over a time. There are many levels of intensity over a period of time. Then, digital signals. What are the digital signals? Digital data refer to information that has discrete states. As an example, data is stored in a computer memory in the form of zeros and ones. Digital data has a limited number of defined values. You can see the graph B. There are 1, 2, 3, 4. 4 number of levels, intensity levels over a time. Moving on to the next slide. Data transmission. Data transmission is the most important topic in wireless transmission. There are two main types of data transmission: digital data transmission and analog data transmission. In the digital data transmission, before transmit the data, we must convert our data to digital form. The two types of digital conversions must be done. First one is digital to digital conversion. The second one is analog to digital conversion. Then analog transmission. In the analog transmission also, there are two types of conversions is involved: digital to analog conversion and analog to analog conversion. We can discuss more about the conversions in the next slides. Digital to digital conversion. To represent the digital data by using digital signals, the conversion involves three main techniques. First one is line coding. Second one is block coding. The third one is scrambling. Line coding is process of converting digital data to digital signals. Line coding is the main method we use to digital data to digital signals. You can see the graphical view of line coding. The sender sends the digital data, zeros and ones, going through the encoder, then digital signal going through the link. After that, decoder decode the data, decode the digital signal to digital data, which similar to sender sends. Then receiver can receive the correct digital data. The line coding, we can categorize the line coding in number of types: unipolar line coding, polar line coding, bipolar line coding, multi-level line coding, and multi-transition line coding. This is the summary of digital to digital conversion. Moving on to the next slide. Analog to digital conversion. An analog signal, such as one created by a microphone or a camera, the conversion of analog signal, analog to digital, involves two main techniques: pulse code modulation and delta modulation. We can see the pulse code modulation process in the next slide. Pulse code modulation, PCM. The pulse code modulation includes three main processes. First one is sampling, second one is quantization, and encoding. You can see the graphical views of PCM. The analog signal sends through the PCM encoder. First, in this process, they sample the analog signal. This is the view of sampled signal. Then after this, that quantizing, this is the quantized signal. Then encoding, the receiver receives the digital data. Digital to analog conversion. This is the one main conversion method of analog signals, digital to analog conversion. To represent digital data by using analog signals, the conversion involves three main techniques: amplitude shift keying, frequency shift keying, phase shift keying. First one is based on the amplitude of the signal. You can see the first graph. Then the second one based on the frequency of the signal. Then the third one based on the phase. Phase means difference between time. Yes, third one is based on the phase of the signal. Then last one is analog to analog conversion. This is the second conversion method of analog signals. To represent the analog data using analog signals, the conversion involves three main techniques: amplitude modulation, frequency modulation, and phase modulation. First one, the modulation using the amplitude of the signal. Then the second one is modulation using the frequency of the signal. The phase modulation is also same as the amplitude modulation and phase frequency modulation. Instead of the carrier amplitude or frequency, the carrier phase is changed. It is not possible to show using pictures. Then, wireless transmission. When talking about the wireless transmissions, there are three main topics in the wireless transmission. First one is radio wave, second one is microwave, third one is infrared, IR. What are the radio waves? What is the frequency range of radio waves? Radio waves includes frequency range 3 kilohertz from 3 kilohertz to 1 gigahertz. The radio waves use omnidirectional antennas to transmit the signals, their signals. Then microwave. The frequency range of microwave signals are 1 gigahertz to 300 gigahertz. The propagation mode of the microwave signals are line of sight. Then the last one is IR. The frequency range of the IR signals 300 gigahertz to 400 terahertz. The IR used to short range of communication. We can see the use of IR in our day-to-day life, in the television remotes, and lots of IoT industries. The next one, propagation methods of antennas. There are three main types of propagation methods. First one is ground propagation. Second one is sky propagation. Third one is line of sight propagation. These three methods involves based on the frequency range. The ground propagation use below 2 megahertz frequency of signals. The sky propagation used to use frequency between 2 to 30 megahertz. Then the line of sight propagation method used to frequencies above the 30 megahertz. Finally, bands of the signal. There are 8 number of bands of the signals. Very low frequency, middle frequency, high frequency, very high frequency, ultra high frequency, super high frequency, and extremely high frequency. The bands categorize using the range of the frequencies of signals. These are the second column shows the frequency range of the signals. Then the third column shows the propagation methods of these bands. Then last column shows the applications of these signals. Application of these 8 number of bands. Then I think you got the recap or summary or some simple knowledge on the wireless network technologies. We can recap our presentation. Yes. We discuss about the layered architecture of network transmission, OSI 7-layer model, TCP/IP model, then the data and signals, bandwidth, filters, transmission impairment, the data can receive during the transmission, and error detection and correction means redundancy, and analog and digital signals, data transmission, and the methods of data transmissions, the processes of the data transmissions, digital to digital conversion, analog to digital conversion, digital to analog to analog conversion, and wireless data transmission, propagation methods, and bands of the signals. Thank you so much for hearing us, and thank you.